In this experiment, I created a model of exponential decay by recording the temperature of cooling water every 5 minutes. I used a calculator, a CBC, a mug, a temperature probe, water, and a water heater. The CBC was connected to the calculator, and the temperature probe was connected to the CBC. This then allowed the calculator to collect the data from the water in the mug. First, we are going to look at the comparison between the water, temperature, and time. As seen here in this table starts at 173.67 degrees Fahrenheit, and then after 45 minutes, the temperature is 99.52 degrees Fahrenheit. Therefore, 173.67 degrees Fahrenheit is the initial condition because at 0, this is the temperature. To find the decay factor, we will take 2 points and divide them. So, if we take the temperature at 5 minutes, which is 157.76 degrees Fahrenheit, and divide it by the temperature at 4 minutes, which is 169.83 degrees Fahrenheit, we will get 0.92893. This is then the decay factor, and because it is less than 1, it is decaying exponentially. To find the initial condition on a graph, you would look at which x value crosses the y value. So in this case, it would be point A. To find the decay factor in a graph, you would take, for example, the point after point B and divide it by point B. This would then give you your decay factor. To find your initial condition in an equation, you would look at the number that's being multiplied by your decay factor, which in this case is this. And the reason that this is your decay factor is because this is the number that's being raised to the power of x. As in here is the data collected from the time and the temperature difference. So here's the equation here, the table here, and the table would be these little drawn boxes, and the graph here. The temperature difference information is important to the problem because it would answer the question of when is the water temperature at room temperature. So looking at the graph here, you would know that when it's at room temperature, when the dot would be on the x-axis. And looking at the table here, the water temperature would be at room temperature when the number that I've drawn here, the difference, is 0, because there would be no difference between room temperature and water temperature. Looking at the equation, to know when the water temperature is the same as the air temperature, or when the difference is 0, you would look at the x, and x would be 0 when this occurs. Okay, so in this experiment, Cool It, I learned 2 things. One was how the equation of exponential decay problem would look like. So I know it's going to be y equals the initial condition, which I learned how to find, times the decay factor raised to the power of x. So this would be the equation for an exponential decay problem. I also learned how to find the decay factor in a graph. I didn't know this before, so yeah. I know now that you take, let's say, point B and divide it by point A, and this would then give you your decay factor, which I could then build my equation with. All in all, I think that this experiment was really cool. It was interesting, and I was able to further understand exponential decay problems and situations. Thanks for watching.